All right. So I think Heather's clearing our screen, maybe. Awesome. Okay, so we will get started. Welcome to today's session number 3 around addition and subtraction. Thanks for joining us. I know it's a lot and it's your time, so we appreciate it.
Here, so.
Oh. Okay, so thanks for taking the time out of your schedule to join us. And today's going to be really centered around subtraction. So hope you tune in and enjoy.
Okay, so today we are going to take the time to dig in with a little bit more focus on that subtraction piece, with some conversation obviously about addition, as they sometimes will go hand in hand. But today's session we are going to be focusing on taking jumps of 10 forward and obviously backwards for subtraction, getting to a landmark number and taking jumps. We are going to dig a little bit into overshoot and return. And we are also going to have some really kind of rich dialogue about using strategic and efficient methods depending on how the problems are posed to students. So we're looking forward to that piece.
All right, and before we get started, we're just going to take a minute to do the traditional territory acknowledgement. We acknowledge that the land on which we are gathered is part of the traditional territory of the Chippewa, Odawa, Potawatomi, and Delaware nations.
Okay, and as we had mentioned earlier, if you were with us, this is our last Zoom session in this series. So again, thank you to everyone who has taken the time. We understand how busy things can be, especially at this time of the year, and we have gotten a lot of great feedback from people. If you have happened to miss any sessions or want to go back and check them out again, all of the archived sessions are on the blog spot. LKELEMpro.blogspot.com, and today's will be put up there shortly as well.
Awesome. Okay, and you may recognize this slide from the beginning. Just wanted to kind of circle back to it. So if you didn't get a minute to think about it, please do so. When it comes to teaching subtraction to your students, which emoji best describes you? Are you screaming in fear? Are you no comment, no opinion, or a high five, a woo-wooer? If you're with somebody, share your thinking with the person beside you. If you're Sally, share it with your dogs. That's fine too. And as we get on that note, then we will introduce our long-awaited special guest.
So again, Heather Wark, the jack of all trades, the expert in everything math, and we welcome her again for our next session. So it's all yours, Heather. Thank you.
Thank you, guys, and I'm really grateful to everyone who's out there in cyberspace participating during the live webinar, or if you're watching this in the playback. Thank you for coming out. I really hope that you find tonight's session useful. If you have any questions along the way, of course, please post them in the chat or turn on your mic and shout it out there, and we will do our best to try to answer all the questions that people have. In the last few sessions, we've been talking about how the continuum helps us to understand that math is actually a developmental, learning math is a developmental process. And so that through the continuum, we see different stages, different phases that kids go through that reflect their understanding and their ability. And that our job as a teacher is to provide them with various experiences that will help push their thinking and expand their understanding in new ways. And I hope that tonight is another session that allows us to explore some new thinking in those areas. The last couple of sessions we've been looking at this problem. Let's pretend that you have 6 fish crackers and I give you 8 more. Do you know how many fish crackers you would have altogether? So this small addition problem, this early addition problem, we've been using that to help us look at some of the strategies. And actually, on Dr. Lawson's continuum so far, we've actually touched on a fair bit of the territory in the last 2 sessions, including all of these circled strategies and some key ideas. In the last session, we focused on these 4 that fall into the working with the numbers phase. And with those small additions up to 20, the ones that we usually consider as, quote, the facts, once students are using these sophisticated strategies to solve the facts problems, the very next thing for us to do with them is to help them to get faster. So they're using sophisticated strategies, but in the beginning, those sophisticated strategies are cognitively challenging and are often quite slow. And so our next step is to help them get faster at them so that those sophisticated strategies lead towards what we call automatic retrieval, which is basically like going through the steps of those strategies, but really fast because they've practiced those pathways so many times. So, for example, going back to the corn analogy that I talked about in session 2, that now that they've got a sophisticated strategy, we actually want them to travel those pathways so many times that they become really easy for them to do. And let's get out that sidewalk paver now and strap on those rollerblades and make those sophisticated strategies really fast so that they can get to a solution in less than 3 seconds. And alongside of that, alongside helping them to get faster, and certainly games and other activities like that will help them to get faster, alongside that, we also want to use some number talks and discussions to explore connections between the facts that they've now learned, like something like 2 + 3, with the related fact 20 + 30. You know, why are those connected? How are they connected? And really having some deep discussions about those connections so that students can utilize those small facts to help them with many addition problems down the road. And that will open the door to being able to solve bigger addition problems like double-digit addition problems. So for example, this problem, which is very similar to the one we just did, but with bigger numbers. So let's pretend that you have 26 fish crackers and I give you 38 more. Do you know how many fish crackers you would have altogether? And so students might think about this problem as 26 + 38, and they might think about 20 + 30. So they might split those 2 numbers and work with the facts that they know. 20 + 30, well, that's related to 2 10s + 5 10s, or that is 2 10s + 5 10s, 2 10s + 3 10s, so that's 5 10s, 50, plus 6 + 8, which brings them to 50 + 14, and then to 64. So students who have those basic facts and we've helped them to extend them up into the double digits will be able to access this type of strategy where they're splitting up those numbers and then putting them back together. So there we see splitting on the continuum, and that pretty much splitting takes us into the territory of using alternative and standard algorithms. So that splitting strategy will help our students get to the alternative algorithms and the standard algorithms. But one thing that we know about splitting strategies is that students who try to use them for subtraction have a lot of challenges. Splitting strategies are very error prone in subtraction. So we need our students to have access to something else to help them. And we usually access it in addition initially and also subtraction. But for tonight, we're going to dig right into how we might do it in subtraction and how this might look in subtraction, just to get into subtraction together. So what about subtraction? Well, one thing we know about subtraction is that it is the most error prone of the 4 operations. It's actually even more error prone than division, which is kind of surprising. The exception to that might be the division algorithm, because there's subtraction in there. And so sometimes that also trips us up, but it really often is the subtraction that causes the challenges. So what can we do to help our students have greater success with subtraction? Let's take a look. So tonight we're going to talk about 5 things that we can do as teachers to help students have success with problems that could be solved using subtraction. So here's number 1. Strengthen the student's understanding of the part-whole relationship. So in the past sessions, we've looked at that part-whole relationship. That's a key idea on the continuum. Well, how do we strengthen students' understanding of the part-whole relationship? Well, one thing we can do is we can explore other problem structures. So instead of looking at, for example, 7 plus 8 equals question mark, we can look at 7 plus something equals 15. And when I was a kid, I probably would have been taught to use subtraction to solve this problem. And our kids will too. Some of them might use subtraction and some of them might use other strategies, but either way, they're going to find this missing piece. So there's lots of different things that you can do here, but here are 2. So 1, play games, and 2, vary the problems. And we're going to dig into both of those for just a minute. So inside what to look for on page 162, there are a lot of games that are about counting on. And counting on games tend to help students with the part-whole relationship. So the ones that I would focus in on for working on the part-whole relationship are the ones that are down here at the bottom of this list. Missing parts cards, piggy bank war, riddles with tiles, and salute. So any of those games would help to strengthen the part-whole relationship that we're talking about here as students move towards subtraction.
Salute's a popular one. It's always a big hit. Oh yeah, big hit in the classrooms.
Yeah, it's really fun.
Yeah,
and you actually don't need 3 players for it. So sometimes it says 3 players and it's fun with 3 players, but if you have you don't need to have 3 players. You can actually have Stuffy or something take the 3rd seat.
Huh.
So
okay,
a little cheater point for if you don't have an odd number or multiple of 3 in your classroom, you can definitely a number of students, you can definitely still play.
Awesome.
So don't let the 3 players stop you.
Okay.
The other thing that I wanted to dig into with you tonight, just a little bit, is the notion that there are actually a lot of different types of problems that we can pose. And in the research, they've actually categorized problems for addition and subtraction into 11 categories. And so you see here, this picture is also from What to Look For, the 11 different problems that you could pose. And we're just going to focus in on 3 tonight, the 2 most common, and then the one new one perhaps that I'm going to suggest that you include in your repertoire to help students construct the part-whole relationship and think about subtraction in slightly different ways. The most common one, the one that we're most familiar with probably, is this addition type of problem. The strategies are categorized based on whether or not they have an action in the problem. And this type of problem has an action in the problem, and that action is a joining action. So you're bringing two sets together in this problem with some kind of action word. And so here's the example from the book. You have 5 gummy bears, your friend gives you 7 more. How many gummy bears do you have now? So that's very much like the fish cracker problem we were looking at. And that problem, because it has a joining action, is called a join problem. And the other way that they categorized it is the action or lack of action, and where the unknown is. And this part was the new learning for me when I was looking at these, because I think we're often writing a lot of different problems and we might have different actions in them, but changing up where the unknown is in the problem writing is a little bit, it was new for me when I first came across it. So I want to take a quick look at what that might look like if we were going to write out, if we're going to look at a problem like that one. So a double digit version, the one that we were just looking at. So here's the one that we just looked at. So let's pretend you have 26 fish crackers and I give you 38 more. Do you know how many fish crackers you would have altogether? So if I was going to write that problem mathematically the way that it is following the action in the problem, I would probably write something like that, or maybe I'd put a question mark. So 26 plus 38 equals something, and I have to figure that out. And so the unknown, the location of the unknown is in this position, and the researchers who categorized it called that the result position. So this problem type was called a join result unknown. So this category up here, join result unknown.
That's definitely the most common type of questions that I use and that I come across for sure.
Yeah, it's our go-to for addition for sure, to write that problem.
Mm-hmm.
And I think to change our kind of mindset there and to come up with those different types of questions is really difficult. So referring to what to look for so that you have almost a format, and just change out the numbers, change out the context. It's a nice kind of starting point to help get you in there.
Mm-hmm. Yeah, she does a good job of sort of summarizing and presenting the different student work that you might see, the different student thinking that the different problems would present. And so we're going to move down to a different problem type here, which is also probably our second most common, the one that we likely ask when we're looking for students to use subtraction to solve a story problem. We probably pose this problem. So something like, you have 12 gummies and you give 5 away. So it has this separating action. The action in the problem is like taking the whole and like removing some, separating some out. And then how many do you have left? So if we were going to write we're going to take a look at a subtraction problem that is a separate result unknown. So let's pretend that you have 64 Pokemon cards and you give away 26. How many cards do you have left? So I'm just going to show, if I was going to write this problem, the way that it's written, I would probably start with the number 64. And then in the problem, you're giving away 26. How many would you have left? So the unknown is also in this position, the same position. We call that then a separate result unknown problem. So here, this separate result unknown. I don't think it's really important that you necessarily have all the vocabulary memorized, but just the knowledge that these are different problems and they will give you different results. I mean, we know that from these first two, right? One of them is going to give us a student using an addition solution likely, and very likely the second one is going to give us a student using what we would consider a subtraction solution, so like a takeaway kind of solution. It doesn't always, and so that's where things get really interesting with subtraction. So the last one that I'm going to talk about tonight is this one in this position here. It's the next easiest problem for kids after the two that we've shown. So it's sort of the next one that you would go to. And this type of problem is called a join change unknown. So this type of problem has a joining action, but where the unknown is located is different. So let's take a look at a double-digit problem that we're going to continue to look at tonight. So let's pretend that you have 27 Pokemon cards and a full set is 42 cards. How many more cards do you have to collect to have a full set of cards? So with this problem, you have, if I was going to write it the way using math symbols, the way that it's presented, I would say that you have 27 Pokemon cards, and you want to collect a full set, but you don't know how many more you have to collect, but you know that a full set is 42 cards. So how many more do you have to collect to make a full set? Do you guys see this type of problem being posed in the classroom?
I don't think that it's one that we see as much. I definitely think that we're really used to those just, join result unknown kind of questions.
Yeah, and separate the separate result unknown. Like I think that's just where we're so used to going. And so like even like this week I was doing a subtraction question on the fly and I 100% did a separate result unknown question because it came to my head so quickly. So I have to start remembering like, okay, I have this table in this book. I need to use it.
Yeah, so this last one is called a join because the action is joining, but it's the change that's unknown. And this type of question opens the door for students to use either addition or subtraction to figure out the relationship there.
Yeah.
Instead of it being a removal action that we would see here, then this is a little bit more about considering subtraction or considering that the relationship we're looking for here is the distance or the difference between those two numbers. And that's a really important thing for kids to be able to understand, that we can use when we think about subtracting numbers, we can think about two different things. We can think about removing, or we can think about distance. And I'm going to just put a little diagram here. So this is 14. And if I was going to ask the question, you have 14 gummy bears and you ate 6, how many would you have left? That would probably promote students to use a separating action, right? And remove those 6 to see what's left. So you had 14 and you ate 6, how many do you have left? And often those are the types of questions that we pose when we think about subtraction. But we also need our students to be able to think about this other way of thinking about subtraction, which is actually, if you have 6 and you want to get to 14, what is the distance or the difference between where you're at with 6 and 14? So those are two different ways we need our students to think about subtraction, and using these different problem types can help us.
And I think too, it's key there for that explicit teaching piece. The kids may not make those connections on their own very easily. So we need to give them the opportunity and provide those visuals and really let them talk through it to gain that confidence and comfort level with those different types of problems.
Definitely. I think that students need to talk about subtraction as distance and subtraction as removal and the connections between the two. I talked in the top about having these connections using exploring number connections between the facts of 6 plus 8 with the related fact 60 plus 80. So that's, using our number talks to really bring out those connections is another thing that teachers can do to help students be prepared for subtraction. Another really important piece for them to be prepared for subtraction is to play games that require adding or subtracting 10 or multiples of 10 from any number. So students are comfortable, for example, if I say 27 and I want you to add 10, what's that going to get me? Or if I want you to add 20, what's that going to be from 27? And you can play games where you go, around a small circle or something where everyone's adding 10 to the last number. Or you can go backwards, you can subtract 10 from any number. And it's interesting because if you start at something like 27 and everyone adds 10, that's a lot harder than if you just do it from what we call the decade numbers. So those even numbers like 20, 30, not even numbers, they are even, but you know what I mean. Those decade numbers, those 20 or 30, adding 10 to those numbers is very easy. But adding 10 from, 26 is a lot harder. So playing some games that require that. And again, we have a whole list of them available in the book. All of these games help students to practice adding 10, either to other 10s or to any number.
I think it's key too to let them go over that 100, because even if they kind of get the rhythm from 27, for example, and adding 10 on 37, 47, 57, 67, once they get to, that 97, they have to make that jump over 100, which really challenges their thinking.
It's a really important point that you're making, Alicia, because going on up and over those next hundreds is just as challenging as it was for the grade ones to just kind of go up and over 10. That's really hard for the grade ones. And for our older students, going up and over 100 and 1,000 and 10,000 are places where students really have to strengthen their understanding of place value and how our number system works. So another thing that we need from our students is to co-construct with them a number line and to use it to model. So our next little segment, we're going to be digging into some of the other strategies that we have left to look at on the continuum, and we're going to look at how do we model those strategies on the number line. Not modeling on the number line, a student who is able to calculate something like this mentally, for example, they're not the ones who need the number line. It's really a way of doing two things. Number one, getting more students in on it, on the conversation, so they can understand what we're doing. And the other piece is it gives the student whose strategy it is a way to write mathematically their thinking if they needed to communicate it. So we're going to take everything pretty much that we've said so far and demonstrate how that might all fit together. So we're going to start with this word problem. So let's pretend that you have 64 Pokemon cards and you give away 26. So this is our kind of standard subtraction problem that would have been categorized as a separate result unknown. And you guys have some solutions that you're going to share with us from this problem, right?
Yes. Don't judge me. Okay. So this is great because I've been spending a lot of time in subtraction the last couple weeks. So what I would do is I would take away 4 cards from the 64, and that got me to 60. And then I would take from that 60, take away another 20 cards, and I'd get me to 40. I have 40 cards left. And then I still have 2 more. So I had to take away, so I have 38 left.
So how many cards do you have left, Sam?
This is a trick question.
No. I hope not.
I have 38 cards left.
You have 38 cards left.
Yeah.
Okay, so one of the things that when I'm working with teachers and they're just particularly, I wouldn't even say if you're just starting to work modeling student thinking, even folks who've been doing it for a while, one of the tricks of the trade is to not try to model it the very first time you hear it, especially with a problem that might give you subtraction on the number line, because students can think about it in a wide variety of ways, and I don't yet know what way that is until I hear it the first time. So I let them say their strategy the first time, and then I know which one they used. So then I can start to try to draw it. So then I'm going to, after she's shared her strategy, I might then say, so Sam, what did you do first? I just want to try to draw out what you did. What did you do first?
Yeah, so I put my 64 on my number line. And
so you started at 64?
Yep, and then I took 4 cards away.
So you took 4 cards away. So then, so you took 4 away, and that got you where?
To 60.
60. And then what did you do?
And then I took away 20 cards.
Big jump of 20. Now, big jump of 20. So one of the things I try to do when I'm modeling on the number line is to kind of make the jumps, and I probably should have made this one a little bit bigger, try to make them a little, at least somewhat proportional. So I'm not going to make it the same size as my jump of 4.
Okay, so I have my 40 left, and then I still have 2 more that I had to take away. So that gets me to 38.
So that gets you to 38. Where's the answer here on the number line, Sam? Where's your answer?
On the where I end.
Where you end.
Yeah.
Right. And so I often call this the destination with students, sort of where you end up, right? So the answer is actually, in this case, in the destination.
I love that.
And so that's where we've ended up with your strategy. I'm just going to flip back to the slide deck so we can take a look at what this one is called. This one is called getting to a landmark number and taking jumps of 10 forward and backward. And people always ask me, because it has the number 10 in here, if it's okay if the student takes a bigger jump, a jump of 20 like you did. And it's absolutely fine. You can just basically read that as a multiple of 10 forward or backwards, and you're good to go. So I'm just going to jump back. So on this one, the first jump that you did got you to this decade number. And so that's how this strategy is labeled. So you jumped back to a decade number, and then you took the big multiples of 10 leap there afterwards. So that's why it situates itself on this particular spot.
Yeah, I'll just make a little note of that destination. I love that. The answer's in the destination.
The answer's in the destination. Okay, Alicia, you had a different strategy for this particular problem.
I did. So I also arrived at 38 as my answer, but I started at the 64 and I took away the 20 first. So that got me to the 44. Then I took away 4 more to get to that easy landmark or decade number of 40. And then at the end, I took away the last 2 cards, and that left me at 38.
Okay, so now that I've heard Alicia's strategy, I'm going to try to model it. So Alicia, where did you start for your strategy?
So I started at the 64.
Okay.
And then I took off the 20 from the
took
26.
that big leap of 20.
Yes, and that got me to 44.
And you landed on 44 there. Okay. And then what did you do?
So then I decided to take off the 4 to get to 40.
Yeah.
And then I took the last 2 cards away to get to 38.
38. So you took that big leap first, and then you kind of did the last bits there.
Yeah.
Yeah. So how did you know to stop jumping? How did you know you were done, Alicia?
Well, I looked at that 26 and I split that up. So I took the number in the tens column first, so the 20 away first.
Yeah.
And then when I got to that 44, I didn't really want to subtract the 6 from there, so I just broke it down into easier numbers. So I knew the 4 plus the 2 more gave me that 6 that I needed to make 26.
So you knew once you'd done the 20 and the 4 and the 2 that you had taken away the 26, so that's where you knew to stop. And where's the answer in your solution here, Alicia?
So on the number line, so the 38 is my answer.
So
in the destination.
Destination. Got it. Your answer's in the destination there. Exactly.
Copywriting that.
Might already be done, I'm not sure.
Darn.
And so your strategy is this other one that we see here on the continuum, this taking jumps of 10 forward and backwards. And the hallmark of that strategy is that the very first step that you took was taking that big multiple of 10 leap. You didn't, unlike Sam, you didn't go to a decade number first and then leap. You just took that leap. And this is a little harder for students. They don't know these leaps, and that's why those games that I mentioned at the top of taking leaps from any number of 10 or multiples of 10 is really an important piece for them so that they can actually do this type of arithmetic. And then you broke up the last 6 so that in a way that was kind of friendly for you to do that last bit of removal. And both of these strategies are using subtraction as removal. So you're starting at 64 and you're taking away or you're removing the 26. And that's partially because of how the problem is worded. But students could do something else. And we'll talk about that in just a few minutes. Okay, we're going to take a look at this second problem that I showed you a little bit earlier. This is the other problem type that that I introduced, or maybe this is something you've been playing around with already. So this one is, let's pretend that you have 27 Pokemon cards and a full set is 42 cards. How many more cards do you have to collect to have a full set? And so you guys have some solutions to this one also.
So check my mic. Okay. So I started from 27 and I jumped 3 to get to 30. Then I jumped 10 to get to 40. Then 2 more to get to 42. So 15 is my answer. I jumped 15, or I have 15 altogether.
Yeah, what is it? What is the question asking?
How many more cards do you have to collect? So I need to get 15 more cards.
15 more cards.
Yeah.
Okay, so again, I want to listen to that strategy a whole time through first before I start trying to write it. Because especially with this type of question, I don't know which way they're going to go. Are they going to start and go backwards, or are they going to start here and go forwards? It could go either way. So you started, where did you start again, Sam?
I started at 27.
Right, 27. And then what did you do?
I jumped 3 to get to 30. That landmark friendly number there.
You got jumped up that 3 and you got to 30.
Yep, and then I jumped 10 more to get to 40.
So you took a jump of 10, and that got you to 40.
Yep, and then I jumped 2 more, and I knew it was 2 more because I'm at 10 plus 3, 13. 2 more is 15. So I get to 42.
So you got to 42.
Yeah.
And you knew to stop there because
Sorry, yeah, I just kind of jumped ahead of you there.
Yeah.
I knew where to stop because I knew that when I add up my jumps, I added 10, or sorry, no, that's my answer. I'm all like, okay, this is good. I knew where to stop because I knew that I got to 42 cards, which was how many was in a full set.
Yeah, so you knew to stop because you hit this number, which was
Yes.
given in the problem. So what is
Yeah.
the answer here, Sam? Because that's kind of where you were going with me. Yeah.
Well, yeah, like my answer is 15 because I did a jump of 10, 3, and 2, and I added them together.
And so where is the answer in this strategy?
In the jumps on the top.
Yeah, and so sometimes we'll say the answer's in the journey.
Oh,
So the answer's in the journey here.
in the journey.
The amount that you traveled is actually the answer. What is the distance between 27 and 42? Well, it's 15.
Right.
15 cards in this case.
That's great.
Okay, Alicia, you have a solution also for this particular problem.
I do. So my answer was also 15, but so I started at 27 and I made a jump of 10 to get to 37. And then again, I made a jump of 3 and I knew that that would get me to 40, which is the friendly number. And then 2 more to get to 42.
Okay, so again, listening first and then writing. So you started at 27 also.
Mm-hmm.
And then what did you do?
So then I made a jump of 10 to get me to 37.
Big jump of 10 to land you at 37.
Mm-hmm.
And then what did you do?
And then from there, I made a jump of 3 to get to 40, because that's an easier number to work with.
3, and that got you to the 40.
Mm-hmm. And then I made my last jump of 2 to arrive at 42.
42. It's hard to fit all those little numbers in there, but
Mm-hmm.
yeah, I could have maybe made my jump of 3 just slightly bigger next time. And so where's your answer, Alicia?
So again, in the jumps that I made, because I knew I was working towards getting to the full set.
In the journey.
It's in the journey.
In the journey.
Yeah. So your answer's in the journey. So you also did this little calculation to figure out what your answer was.
Right.
And so we'll see students do this as well. And this is one of the things that using that join change unknown problem will help us get, because with the join change unknown, because it's a joining action, we'll often see students using and adding up to find the distance or the difference between those two numbers, because the action in the problem prompts them to do so. I'm just going to go back to the slide deck. So Sam's first strategy, and we'll take a look at it in a second, is back to this one, the getting to a landmark number and taking jumps of 10 forward and backward, because she got to this, she did the jump to 30 first to get to that decade number, and then she did the jumps. Whereas for Alicia, you did, again, taking jumps of 10, in this case forward, and the reason why I know that is because the very first step that you did was that leap of 10, and then you figured out the rest. So when you're trying to figure out a student strategy, which one is which, you're looking at what's the very sort of first thing they did. Did they go to those decade number first and then take leaps, or did they just leap from wherever they were starting? So the last thing, we've just got a couple of minutes left. So the last thing that I wanted to talk about that supports students to use a variety of strategies. Maybe sometimes they'll add up and sometimes they'll subtract, or work backwards. Remove. Sometimes they'll think about it as removal, and sometimes they'll think about something as adding up. We can support them to do those things based on the context or the problem type. So we just talked about that with this join change unknown problem. because there's a joining action, it will encourage students to think about adding up to find the distance or the difference. Number choice and putting those number choices into a sequence, so one problem after another, will support students to use maybe a mental or a physical number line to help support their thinking. So something like a race, a long distance race, for example, with different checkpoints might help them to think about a number line. So I put this problem together to help with the last strategy that we're going to talk about from the continuum tonight, and that is, here's the problem. Let's pretend that 64 people are on the bus, and when they reach a popular stop, 30 people get off the bus. How many people are left on the bus? And I think if we pose this problem to students, given the context, they are very likely to jump back 30 from 64. The numbers are very friendly. 30 plus 30 is 60, so that's maybe a fact that they know. And we're going back a nice friendly number. And so it's very likely that they will just jump back either 54, 44, 34, or just one big jump of 30 to get to 34 on this problem. And I think a lot of our students can likely do that mentally. So they would probably do something, it would look like that. And then I would pose a second problem. So let's pretend that 64 people are on the bus, and when they reach a popular stop, 29 people get off the bus. How many people are left on the bus? And I think that in this case, students, because we just asked the last problem, will be more likely to give us a different strategy, because they're hopefully going to utilize the last problem. So a lot of students hopefully will just lean on the fact that we just did this problem. So 64, take off 30 to get them to 34. And so all they have to do is, if they want to just take off 29 instead, is to go up 1 so that this distance is actually 29. There's a lot of really important conversation that can happen around how that works. And that's the reason why I posed it in the context that I did, the story that I chose with people getting off the bus, because hopefully they'll be able to come up with a story where this would happen. For example, they got to the stop and 30 people got off the bus, but then the bus driver calls one kid back on, or one person back on, and says, hey, this isn't your stop, get back on the bus. So now only 29 people got off and there's 35 left. So utilizing a story, picking a story that's going to help them to be able to understand when the math gets really hard, as in this case. So this is our final strategy for tonight, this overshoot and return, in this case in subtraction, which is really challenging for students, but hopefully with all the other steps that we talked about, and using a context where they might be able to maybe act it out and really understand it, would help make it more accessible.
Awesome. All right.
Oh, I'm just going to back up one more step, because I forgot that these 3 pieces here, they end up building towards what we call using strategic and efficient methods, meaning that students, when they're in this layer of proficiency, where we call it using strategic and efficient methods, they'll have the ability to utilize any one of these 3, and they will use whichever one, forward or backwards, or using overshoot and return, and they'll be able to pick it based on the numbers that are presented with that are presented in the problem. And that's really when we see what I would call it using strategic and efficient methods, when they're able to actually select which strategy based on the numbers. That's the end. That's all I have.
That's great. Go ahead, Alicia. I'll let you chat.
Okay, so again, Where can you go to learn more? Ask a colleague, connect with a coach that's in your building. Don't forget the blog spot is there. Find a copy of what to look for in your building. Also remember that those archived sessions are on the blog, so go back, refer to them. I know there's a lot of information we kind of push out in a short amount of time, so again, we just appreciate you being here. Heather, we appreciate you so much. Thank you for taking the time to dig into this with us as well.
And yeah, again, we'd love some feedback. So this will help us move forward. If you can provide some, that would be great. Just take a minute, scan the QR code, and share your thoughts from today's session would be greatly appreciated.
And this one I think is more focused towards just overall with all the sessions, what your feedback is, what you would like maybe us moving forward to provide for you. So it'll help kind of guide our direction moving forward.
Awesome. So thanks. We are finished. And Heather, thank you again, because like that was great.